So this is the review key video for Unit 7 review sheet. So here we go. So we have a function. What we want to do is we have a table of values. We want to be able to fill in the table and graph those points on our coordinate plane given this function. Now here's the function. Right there, 3 to the x power. So we're going to put these values, -2, -1, 0, 1, and 2, in for the x value to figure out what it comes out as when you take 3 to those x values. So 3 to the -2 is 3 squared, and then because it's negative as an exponent, the 3 goes to the bottom of a denominator and becomes 1/9. 3 to the -1. 3 to the first power is 3, and with the negative exponent it becomes 1/3. 3 to the 0 is 1, 3 to the first is 3, and 3 squared is 9. So we're going to take those points, and then we're going to graph them on our coordinate plane, and then we're good. So we have -2, 1/9, which is going to be about here. We have -1 1/3, which is about there. We have 0 and 1, 1 and 3, and 2 and 9. So our graph's going to look something like this. It should not go underneath the x-axis because, well, it's an exponential function and they don't do that. So that is the first graph with its table. Now what we're supposed to do is make a table of values for its inverse. So the inverse actually for this is going to be pretty easy. We're going to take the x values right here. We're going to put them in the y column. -2, -1, 0, 1, and 2. We're going to take the y terms from our first column, or sorry, for our first problem, put them in the x column. So 1/9, we have 1/3, 1, 3, and 9. Now we're going to take those points and graph them on our coordinate plane. So we have 1/9 and -2. We have 1/3 and -1. We have 1, 0. We have 3, 1. 9, 2. I'm going to graph this. There we go. So now we have our table of values and our graphs. Okay. Next, we're going to find the characteristics of each one of the graphs, so the regular function and the inverse function. So we're going to do the regular function first. Okay, so the domain of the regular function, what x values exist in this graph? All right, so if we look from left to right, the graph is always going to go left. It's always going to go to the right. So it would be from -infinity to +infinity. The range, as we look from the bottom to the top, the graph doesn't start from the bottom until it hits 0, and then it goes up to +infinity. All right. The asymptotes, that invisible line that is a boundary for the graph, I'm going to draw it in right here. It's right here on the x-axis, which is why the graph can't go underneath the x-axis, because there's an asymptote there. And the equation for that asymptote is y equals 0. All right. The x-intercept, well, because the asymptote is on the x-axis, this does not cross the x-axis. That means there is no x-intercept. The y-intercept, going back up here, where the graph crosses the y-axis is actually this point right here, 0, 1, which again is right there on the graph. Intervals in increase and decrease, well, it is increasing the entire time. So we're going to put increase over the entire domain. And lastly, it's end behavior. So first we start off as x approaches -infinity. So we'll go back up the graph, see what happens when the graph is approaching -infinity. So as the graph goes to the left, where is it going vertically? Is it going up or down and towards what? Well, as it goes to the left, right here, It's always going down, but it's always going down towards 0. So as x approaches negative infinity, f of x approaches 0. All right. Then the next one is as x approaches positive infinity. So as the graph goes to the right, let's go back up here and figure out where that is. So as the graph goes to the right, here it's going to the right, but as it goes to the right, it's also going up towards positive infinity. So f of x will approach positive infinity. And that's the regular function characteristics. Now we go to the inverse function characteristics. Okay, so a lot of these are similar to the regular function, but they're flipped. So for the domain, as we look from left to right, the graph here doesn't start on the left until you get to 0. Then it goes to the right towards infinity. So notice how the range of the regular function is the domain for the inverse. Now let's look at the range, going from the bottom to the top. So the graph keeps going down here, and as it goes to the right, it keeps going up, which means the range is negative infinity to positive infinity, just like the domain is for the regular function. All right, these asymptotes, I'll draw on the equation or the line for the asymptote. It is right here on the y-axis. This line will never cross the y-axis, our graph, because the asymptote is there. And the equation for the asymptote is not y equals 0, but it is x equals 0. Okay, the x-intercept is next. The x-intercept is actually right here in the table, and right here. There it is. Couldn't see it at first. Right there in the graph. And that is 1, 0. Okay. For the y-intercept, because there's an asymptote on the y-axis, that means there is no y-intercept. Okay. Increase and decrease intervals. So I'm going to accept two things for this, because I think during the time of class I might have mentioned two different things, but either one is fine. I'll accept them both. All right, the graph is increasing the entire time it's going up. Okay, so I would accept it's either increasing over the entire domain, or if you said it's increasing from 0 to infinity. Either one I'd accept, because the domain is 0 to infinity. All right, last one is the end behavior. So as x approaches, well, in this case, we have to look more carefully at the graph, because as we move to the left, we're not approaching negative infinity, because we can't get over to negative infinity because the vertical asymptote that's sitting in the red dotted line. So the graph, as it goes to the left, is only approaching 0. Okay, and as the graph I even wrote that wrong. This would be as x. Here we go. As x approaches 0, f of x will approach negative infinity, because as it approaches 0, it keeps going down. On the other side, as x approaches positive infinity, because it's going to the right, let's go back up to the graph and check it out. As x approaches positive infinity, which is, again, over here, all right, the graph is also going up at the same time, so it's approaching positive infinity. There we go. Those are the characteristics of our regular graph and our inverse. Okay, next, do the same idea, but this time the first equations we were dealing with, 3 to the x power up here, this is an increasing function because the b value is greater than 1. We're going to look next is a decreasing function because the b value is between 0 and 1 because it's a fraction. and it's less than 1, but it's greater than 0. So we have to do the same kind of thing, and the same rules apply. All right, we're going to take the 1/3 and raise it to the -2 power to fill out start to fill out our table. All right, so if we did 3 squared, it would be 9, but the negative sign is going to make the denominator, the 3, go up to the top to become just regular 9. Same thing happens with the -1. 3 to the first power is 3. The negative is going to make it go from the denominator to the numerator, so from the bottom of the fraction to the top, which gives us just 3. 1/3 to the 0, just like before, is going to be 1. 1/3 to the first power is 1/3. 1/3 to the second power is 1/9. You're just squaring the two numbers. So 1 squared is 1, 3 squared is 9. We're now going to take these values and plot them onto our coordinate plane. So we have -2, 9 is right here. -1, 3 is here. 0, 1, 1, 1/3, 2, 1/9. There we go. So here's our decreasing function. Okay. Now, again, like before, we take our table. The x values of our table become the y values. So we have -2, -1, 0, 1, and 2. And the y values of the first table become the x values of the second. So we have 9, 3, 1, 1/3, and 1/9. Okay, so now we can take those new points and plot them on our coordinate plane. So we have 9, -2. We have 3, -1. We have 1, 0. 1/3, 1. 1/9, 2. And here we go. Beautiful. And there's our graph. So just like before, we're going to find the characteristics of these graphs and write them down. So we're going to do the regular function first, the g of x. Okay, so first the domain. So we're looking from left to right. The graph, as it goes up, keeps going to the left, and it's obviously going to the right. So the domain for our g of x function is -infinity to +infinity. All right, next we're going to do the range, going from the bottom to the top. So the graph here doesn't start from the bottom up until it hits 0, and then it keeps going up. So our range is going to be from 0 to infinity. The asymptotes, like before, and I'll draw it in here. The asymptote is on the x-axis, so that's why the graph has a range of 0 to infinity, because it doesn't go below the x-axis. So our asymptote equation, again, like before, is y equals 0, just like the one above. Our x-intercept, because the asymptote's on the x-axis, there is no x-intercept. The y-intercept, as we saw in the previous problem, is right here, 0, 1. So we're across the graph, or the graph crossed the y-axis. So we're going to have 0, 1 for our y-intercept. Our intervals of increase or decrease, well, this one is going down the whole time, so it is decreasing over entire domain. And lastly, the end behavior. So as x approaches -infinity, so if we look back up at our graph for this, as the graph goes to the left, what is it doing? As our graph goes to the left, it's going up. So we write down towards, the graph goes towards +infinity. So f of x approaches +infinity. All right, and then for the other one, as we look to the right on the graph, which is approaching +infinity, which way is the graph going? So we zoom in here. As our graph goes to the right, it's also going down, but it's not going down towards -infinity because the asymptote is there. It's going down towards 0. So that's the end behavior. Now for the inverse function, going back up to the top. All right, the domain from left to right, the graph doesn't start from the left until it hits 0. And then it goes to the right towards positive infinity. All right, again, you can see the flipping of the domain and range for each of the functions, the regular versus the inverse. Okay, the range from the bottom to the top, the graph is below the x-axis. It keeps going down as it goes to the right, and then it goes up as it keeps going up towards 0. So it's going to be from negative infinity to positive infinity, just like the domain was for the original function. All right, our asymptote. Draw the graph or the line of the asymptote again. The asymptote again is on the y-axis. That's why the graph can't go across the y-axis. Okay. And the equation for that the equation for that line or that asymptote is x equals 0. All right. X-intercept, we see that here in the table and on the graph. Graph crosses the x-axis at 1, 0. And because there's a asymptote on the y-axis, there is no y-intercept, so this would be the none. All right. Looking at the graph increasing or decreasing, the graph is going down. So again, I accept two things for this one. So it is decreasing. Yep, that's okay. Over entire domain. I would also accept 0 to infinity, because that is the domain. And lastly, the end behavior. So as x approaches, well, let's go back up and look. We're going to the left first. So as x approaches, well, the x can't approach negative infinity because it can't get past that asymptote on the y-axis. So it is approaching 0. What is the graph doing as it approaches 0? It's going up towards positive infinity. All right. Then on the other side, as x goes to the right, it approaches positive infinity. Let's go back up and look at the graph. So it's going to the right, approaching positive infinity, and as it goes to the right, it's also going down towards negative infinity. And that's the end behavior. Excuse me. All right, next, we're going to transform these equations, these exponential equations, into logarithmic equations. Now, it doesn't say inverse because there's no x and y to flip. It's just rewriting them as logarithmic versus exponential functions. Okay. So, to remember this 3 is the base. This is the exponent. Oh, let's rewrite this. Hold on. Let's try that again. This is the base. This is the exponent. Exponent. I just spelled that wrong. Exponent. There we go. And this is the answer. So when you write logarithms, you're going to have log with a base of 3. The answer 27 equals the exponent of x. Okay? That's the way you're going to write it out. All right. Now, which side it's on is irrelevant. The base of the next one is 1/3 because it's the base of the exponent. 27 is the answer, and the x as the exponent goes out at the end. Here, the base is 27 over 3. The answer is 5 over 9. And the exponent is x. And lastly, the base is 2. The answer is x. The exponent is 7. Okay. Now we're going to do the same thing, but this time we're going to use the logs and change these to exponential equations. Showed you this in class. You're going to smash the log. It causes the base of the log to become the base of that exponent. So we have 3 to the 8th equals 6,561. Smash the log. The base goes over here, becomes the base of the exponent 4, which equals x. Now this log doesn't have a base written down. We've talked about this in class as well. If it doesn't have a base written down, it's automatically assumed it is a 10. So when we smash the log, the 10 goes over, becomes the base of the exponent x, which equals 4. And then last but not least, we didn't talk about this. This is called the natural log. It's the same idea, all right? But because we didn't talk about it, we're just going to make this into a log. The base of the natural log was something else besides 10 because it's a natural log, but we're going to make this base 10 because we're going to change this to a log. Again, we smash that log, the base becomes over here, the exponent of 6, which equals x. Okay. We didn't talk about natural logs because, well, we didn't do some of the other things we used to do with natural logs in this unit. All right. Next. So the graph of a logarithmic equation of f of x is shown. So there we go. That's the graph that we have. And we're transforming or translating it to a new position. So we got to figure out what this new position means. So the -1 is on the inside, which means it's a horizontal shift because it's being subtracted and it's going to the right by 1. And the -4 on the outside is a vertical shift. We're going to follow the sign. It's going to go down by 4. So we're going to take the points that we have. We have 3 points in our current graph. We are going to move them 1 to the right and down by 4, each one of them. So 1 to the right and down by 4. 1, 2, 3, 4. There's 1 point. To the right and down by 4. There's another point. Down to the right and 1 by 4. It's going to be about here. So this is the new home of our graph. So everything about it has moved over. Okay. Now it says describe how you transformed each reference point to the graph to create the graph of k of x. Oh, sorry. We're supposed to graph. All right, make sure you read the direction. It says graph and label the function. So we did graph it, we didn't label it. It's supposed to be k of x. So make sure we do that. So describe how we transformed each function. So we did a vertical, we'll do that. We'll do it in order. Oy. Did a horizontal shift. To the right by 1. We did a vertical shift. Down by 4. And that is how we got the new graph. Okay, it is important that you read the directions. I didn't read the directions very well the first time I did this problem, but then when we said to create graph k of x, I noticed the directions here, graph and label the function. The label is an important piece of the equation, or sorry, of the problem, so please make sure you do that on the test. Okay, same idea. All right, we have a logarithmic function graph. We want to translate it using the function notation we have down here. So the positive 7 means we're going to go to the left by 7. The positive 3 means we're going to go up by 3. So we're going to take these 3 points and do just that. So we're going to go over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That's the first one. Then we have down 1 to the left by 2, and then we have this one. So here is the new graph. Okay, and again, everything moved with the graph, even the asymptotes. All right, our new graph is again called k of x, so we're going to label it. And then we're going to figure out what the transformations were. We had a horizontal shift. To the left by 7. We had a vertical shift up by 3. Alrighty. Moving on. Ooh, solving equations. Love it. All right, so this goes back, harkens back to one of our first tests this semester. All right, what we have here is a quadratic of some sort. All right, what we can do is we can take the greatest common factor of 2 and x out of both terms because they both have at least a 2 and an x. If we take a 2x out, we're left with x squared minus 25 equals 0. Now the x squared minus 25 is a difference of two squares. So we're going to have 2x, and then we're going to have the factors of x minus 25 are x plus 5 and x minus 5. Now all we do is we take the three factors that we have. We have 2x, set it equal to 0. We have x plus 5 equal to 0, and x minus 5 equal to 0. We solve each one for x. The first one we divide 0 by 2, and x equal 0 divided by 2 is 0. The next one we have to subtract 5, and the last one you have to add 5. These are the three separate answers you should get for this particular problem. Next, B. So these are just difference of two squares. So x squared minus 49 is x plus 7 and x minus 7. X squared minus 9 is x plus 3 and x minus 3. So we're going to take all of our factors, set them all equal to 0. And then we solve. Pretty simply, we have negative 7, positive 7, negative 3, and positive 3. Those are answers. Next, we have radical equations. Now these are the ones for both of them. Because there's an x that's not inside the square root sign, we're going to have to check our answers later when we finish solving this. So the first step would be to actually add x to the other side so that when we square both sides, we get rid of that square root sign. So we have the square root of 6x minus 5 equals x squared. Oops, sorry, x, just x. Now that we've done that, we're going to square both sides so that we can get rid of the square root sign. So we're going to go for the 6x minus 5 equals x squared. Next, we're going to move the 6x and the 5 to the right because I want to keep the x squared as a positive number or a positive variable. Those two things cancel, so we have x squared minus 6x plus 5, all equaling 0. Now this becomes a quadratic that we can factor. The only two factors of 5 are 1 and 5. Since they gotta be negative to make a negative 6, those are our factors. We take our factors, set them both equal to 0, and solve. All right, now, because the x squared was on the outside, the x was on the outside of the square root sign, we have to put these answers into our equation to see if it works out right. So 6 times 5 is 30, minus 5 is 25. The square root of 25 is 5, and 5 minus 5 is 0, so that one checks out. All right, next one, 6 times 1 is 6, minus 5 is 1, the square root of 1 is 1. 1 minus 1 is also 0. So these both work. So we're good to go. All that stuff I just did in my head. You can show you the work, but I just did in my head. All right, next. Same idea as the one before. We have to get the square root sign by itself by adding 9 to the right. So we have the square root of negative x plus 6 equals x plus 6. Now that this is done, I can square both sides of my equation to get rid of the square root sign. So I have negative x plus 6 on the right. But on the left, negative x plus 6 is on the left, equals. On the right-hand side, I have to square x plus 6 as a group. So I'm going to get rid of the 2 here and multiply it by x plus 6 again. When I distribute x plus 6 times x plus 6, I will get x squared plus 6x plus another 6x plus 36. All right, I'm going to combine all my terms on the right-hand side because I want to keep the x squared term as a positive. So I'm going to add x and subtract 6. These go away, and I'll be left with x squared. 6x plus 6x is 12, plus 1 more is 13. I just lost, my apologies, I got to get out of this, go back into it because I lost my pencil. Sorry, that was annoying. There we go. So again, 6x plus 6x is 12, plus 1 more is 13. 36 minus 6 is 30. And that equals 0. Now I can factor this. The two numbers that multiply to be 30 and add it to be 13, got an X there, is 10 and 3. So if I set both of those equal to 0 and then solve them, we'll get x equals -10 and -3. Now again, because there's an x on the outside, I have to check this out and make sure it works. I'm going to actually do the equation. I'm going to rewrite it over here. Square root of -x plus 6 equals x plus 6. I'm going to use this as the equation I had because it's going to be easier to solve by when I added the 9 to the other side. So I put both the values in. So -10 times a negative gives you positive 10. 10 plus 6 is 16. The square root of 16 is 4. On the other side, -10 plus 6 is -4, and that does not work. Because 4 and -4 are not the same thing. All right, now for the -3. -3 times -1 is +3, plus 6 is 9. The square root of 9 is 3. -3 plus 6 is also 3. So the only part that works for this one is -3. All right. We've got 2 more questions. These involve Desmos. So I'm going to go onto Desmos, see if I can pull it up here. Okay. So what we're going to do is we're going to find points of intersection between these two equations. Let's get rid of this stuff. Okay, I'm going to type in the first one. So I have the square root of x, oh, that's not x, x plus 3, and then minus 6 on the outside. So that's my first equation. My second equation is x times parentheses x squared minus 4 parentheses minus 4. So those are my 2 equations. So you can see here my it's getting worse. My intervals are very off. Let's make it big. Okay, so there's the 2 graphs. The green graph is the one on the equation on the top. The purple graph is the one that's all squiggly. And we want to find the points of intersection. So actually, there's 3 points that we have to find. So that we have this one, and it also says round to 2 decimal places if needed. Well, it's needed. So we have negative 2 point, I don't like that. 1, 2, comma, negative 5.06. That's the first one. Then we have the next one, I'm going to put it underneath, is 0.06, comma, negative 4.25. Then we have a third one right here, which is 2.03, comma, negative 3.75. So there's 3 points of intersection we got to write down. So just make sure you get them all. Okay, make sure that when you're doing this, you zoom in really well so you can see the lines and where they're going to intersect, if that's one of the questions. All right, next question. We're going to get rid of these equations. We're going to graph this one. So we have 3 to the x power minus 6 parentheses x plus 1. We got that. That's what we got. Okay, so we want to find 2 things in this case. Oh, so I forgot we got to graph this. So it was No. And something like this. All right. Sorry, that was my bad. So I should have graphed it. All right, this one looks a little bit weird. So it looks a bit like this. And we're going to find two things, the x-intercept and the y-intercept. So let's find the x-intercept first. That's where the graph crosses the x-axis, which is that point right there. So we have negative 0.94, comma, 0. And we want the y-intercept, which is down here, which is 0, comma, negative 5. There we go. And that is our review sheet. So hopefully this helps you. Good luck in your studying, and test is on Friday.